Alright, so I chose to do a recommender system. It's a user-based recommender system based on the books crossing dataset. That dataset has a SQL table of users, books, and book ratings per user. And I stored that in a MySQL database running on AWS, and then I wrote the application in Django and Python. So I'll show you how it works here. You just search for your book. So let's say I'm looking for 1984. It does the calculations behind and then returns the cover for my book and then 5 recommendations. So I can click in here and then I have an Amazon link. So I'll dive into the code. The first few functions are all the similarity functions I use for the k nearest neighbor calculations later on. This index function just returns that default page with the input box. A bulk amount of the work is done in this detail function. So when you search for the book, it returns or does an AJAX call to the books table and then returns the book title along with the ISBN and appends that to a data element in the HTML, which I grab in my JavaScript code, which then does another AJAX call to this detail function in my views.py, gets that book that I'm searching for in the books table, does some URL stuff for bad images, and then calls the recommend function, which takes the ISBN number of the book you're searching for, so in this case 1984. In here, this is really done to go through the SQL tables and get data where the users have also rated the book you're searching for, so in that case 1984. It'll go through the ratings table where the ISBN equals the one you pass in, and then order that by the rating in descending order. And then I grab the user IDs from the model results and append that to this list. So I have a list of user IDs, which are users that have rated 1984 as well. And then in this results variable, I grab the data for each of those users. I read it into a pandas data frame. I had to use a library called djangopandas.io, and then I transform or pivot on that that data frame. So I have the index as the user IDs, the columns as the ISBNs, and the values as the book ratings. And then I get the column values, which will be all the ISBNs tied to those users. Store that in this list, and then I have a data matrix where this is just the rest of the data under those ISBNs. So I have the user IDs as the indexes, and all the values in that matrix are the book ratings, and then I fill the NA values with 0. So then this get similar books function gets called, which is really just the k nearest neighbor function. It gets a data matrix, the list of ISBNs, the ISBN you're searching for, so for 1984, and then the k, so I have that default as 5, and then I use the Euclidean similarity function as my metric. So first it grabs the index of the ISBN that I'm looking for, so 1984. It transposes the data matrix and then loops through this data matrix and calculates the distances between the matrix of 1984 versus all of the data matrices that are stored in that table, and then appends this to the distances list here. And then I sort the distances in descending order, and then I have to remove the first element because that will be the book that I'm searching for. We don't want that as a recommendation. So then inside of there, I loop through k times and then append that to the target's list, and then return that targets list to the recommend function, which is the similar books, and then I get all of the book data for that ISBN and return the final results to the detail function. And then this gets rendered out to the page and is what's shown to you when you search for 1984 at the bottom here. So overall, it was a pretty awesome project to put into an application and have all the image assets and everything showing. We worked on that for the joke data set, and it was complicated but not as hard as I thought to put into practice. But that's all my code and the application, and thanks.